Okay. So here's what they told us. They want miles per gallon. This word per. So when they ask for miles per gallon, the word per means to divide. So if they want this as a unit rate, we're just going to divide it all the way through. 138 divided by 6. And you can just plug it right in. 138 divided by 6 gave me 23. So 23 is the answer, and then make sure you label it. We would write it as miles per gallon. And that's usually how gas mileage is displayed, miles per gallon like that. So 23 is not that great, but it's not terrible either. Somewhere in between there. Okay, next one. Walmart sells a 12-pack of soda for $3.98. What is the unit cost? So again, let me jot it down. $12-pack. $3.98. And the cost. Okay, when they ask you specifically for unit cost, money comes first. So $3.98 divided by 12 cans. And again, I'm just plugging it in. 398 divided by 12 is the 0.3316, and the 6 repeats. So I'm going to jot this down, and we'll talk about rounding. Okay, now this is money. So it's price per can. Usually we round money to the nearest cent, the nearest penny. So we're going to round that digit off. Unless they tell you to round it otherwise, you round it to the hundredth, the second place. So if that's what we're rounding, the digit to the right tells me what to do. That's a 1. So I'm going to leave the 3 alone. And that comes out to be about 33 cents per can. Okay. All right, so here's the last one for this. Apple juice comes in a variety of sizes and packaging options. Find the unit price per ounce and determine which is the best buy. Okay, so for choice A, it's 48 ounces for $1.69. Choice B, 64 ounces for $2.39. Choice C is a 10-pack of 6-ounce cans. And that's for $2.99. So first we have to find the unit price for each, and then we can compare. All right, so here's all the information. So to get the unit price, it doesn't matter how they display the information, the money always goes first. So I need to divide $1.69 by the 48 ounces. And I'm going to plug that in. So 169 divided by 48 is giving me this. So again, I'm going to just jot it down, and we'll talk about how to round this in a minute. Okay. Then for B, divide 239 by 64 ounces. And I got this. Seven, 3, that keeps going. Okay, and then for choice C, you're buying a 10-pack of 6-ounce cans. So, how many ounces is that? How many ounces do you get for $2.99?
60.
60. So make sure you keep everything consistent. Everything has been in ounces, so you need to figure out what is the total ounces that you're getting for the price you're charging. So $2.99 divided by 60 gave me that. Okay, 0.498, and that put fine. All right, now let's compare. Let's take a look at what happened here. This is the price per ounce for each of these choices. Clearly, this one here is out. That one's not the better buy. But I want to talk about how we should round this real quick. If we round these off to the nearest penny, for example, then this 3 is in the hundredths place, that's the penny. And the 5 that's to the right of that would tell you to round that up and make it 4 cents. So that's about 4 cents per ounce. Okay, if we do the same thing for the second choice, the 3 is in the hundredths place again, the penny, and then 7 to the right of it has you round that up as well. Okay, this last one, the 4 is in the hundredths place, that's the nearest penny, and the 9 to the right of it would have you bump that up, and this would be about 5 cents per ounce. So clearly, this one is the most expensive. That is not the better buy. Now it's down to these two here. Technically, these two, they look like they cost the same, but technically the first one is a little bit cheaper because if you look before we rounded, the 5 is less than the 7. So if they make you pick one, if you have to pick one, you would go with the top one. But if they don't specify, then these both round off to be equal. So either one of these could be the better buy. In real life, we pay by the penny. Does that make sense?
Yeah.
Okay. Let's continue then. We'll just I'm going to pick out 2 of these to do. Just try to practice and then we'll keep going. So let's look at number 4 first. Car travels 775 miles in 10.5 hours, 10.5 hours. What is the rate in miles per hour? What they want is what is the unit rate. So we're going to take the 775. And by the way, they'll tell you in the question usually how they want it divided. they say miles, then per hours. So miles comes first. So 775 divided by the 10.5. Okay, since they want to know how many miles per hour, you're just going to divide this all the way through. 775 divided by 10.5 is about 73.8 is what I'm getting. So that's, I would just round that off and make it about 74 miles per hour. Make sure you keep them in the right order. And when you read it back, it should read back the way that they're asking you for. Okay. That person was speeding. All right, let's look at number 6. So you're at the grocery store comparing 2 different brands of peanut butter. Jif has an 18-ounce container for $3.28. Smucker's has a 28-ounce container for $4.89, which is the better deal. So when they ask you that, they're asking you to find the unit price and then determine which one is cheaper. They are not asking you to figure out which one you like better. If you're a Jif fan, you just have to put that aside for now. Okay, so let me just write it down. $4.89 for 28 ounces. Money always comes first when you're asking or you're working out unit costs. All right, let's see what we got. 3.28 divided by 18 gave me about 18 cents when I round it off. So it's about 18 cents per ounce. And $4.89 divided by 28 is about 17 cents. After I round it, because I see a 4 here, so that'll keep the 7. So the second one is the better deal. Okay. That's it for that. We're going to move on to proportions. Any questions before I do that?
Nope.
Okay. Okay, so here's the other thing we're going to talk about today. A proportion. What is it? A proportion is 2 ratios that are equal. That's it. 2 ratios that are equal. And they look like 2 fractions set equal to each other. They're also known as equivalent fractions because they are actually going to be equal, but commonly they're called proportions. So here's what's nice about them. These are used to solve all kinds of different applications. You can bring them in and solve just about anything with a proportion. Because since you have 4 values, there's 1, 2, 3, 4 in a proportion. If you know 3 of them, you can get the other one. You can get the 4th one. And that's why these are so useful. So we're not going to set up necessarily 2 fractions that are equal. What we're going to do is solve proportions that look more like this for that missing 4th value. And then we'll talk about how you use it in a word problem. So to solve a proportion, you cross multiply. Okay, now keep in mind This is different than if you were multiplying two fractions. Now these two fractions are equal, so you can't cancel, you cross multiply. Right, that's the biggest mistake I see people make, is they confuse the two things. So I want to make sure that that makes sense before we talk about anything else. All right, let me give you an example. Let's go, you know what, let's go with the one that's there. 1/4 equals 10/40. This, when they're equal, this is a proportion.
What is that, man?
Huh?
That's what I thought it was.
Okay. Good morning. Okay. When they're equal, it's a proportion, so you cross multiply. When you are multiplying, this is when you can cancel. Okay, they're two totally different things. You can't combine them. You cannot do, for example, 4 divided by 2 and 10 divided by 2. You cannot do that here. What you do instead is you multiply the 4 times the 10 and set it equal to the 1 times the 40. That's called cross multiplying. So 4 times 10 is 40. 1 times 40 is 40. And that always back. If it does not, if you get two different answers when you do that, that means that these were never equal to begin with, and this is not a proportion.
So when you're doing this right here,
yeah,
you gotta just cross multiply them. You don't cancel them out, and they should like 40 on the bottom, 40 on the top. So that means the proportion is correct.
Yes. Yep. And okay. They'll actually, let me show you this here. They're going to ask you questions like this to determine whether the proportion is true or false, and that's what they're asking you to do. Cross multiply and see if you get the same thing. And then as far as these go, these, we're going to find the missing value here. We're going to do that right now. Okay, so let me just erase all this. This one here, you're starting off with 3/4.
Oh, I get it. I get it.
And they want to know what would go up here that would make these two things actually equal. So cross multiplying is the easiest thing to do. I start with the two that have the x. So this would be 4 times x. And then I'm going to set it equal to the other two. 3 times 20. Now, when you write this, 4 times x is just written as 4x. And 3 times 20 is 60. So you want to take another step and simplify it right here. And now we haven't talked about algebra too much yet. I've been mentioning it here and there, but we haven't done the chapter yet. So what I'm going to tell you as a kind of a preview to all of that is, if you don't know what to do right here, the last step is always to divide by whatever is in front of your x. So you're going to cross multiply first and get it set up. And that's this step right here. Then always divide by whatever is in front, by the number in front of x. Whatever that is. It could be x, it could be a different variable, but divide by whatever is in front of whatever you're solving for. So I'm going to divide this side by 4, and I'm going to divide this side by 4. The reason I'm going to do that is because 4 divided by 4 is 1. And that's what I want. I want to know what 1x is. I don't care what 4x's are equal to. I need to know what x equals. We don't write the 1, we just write x. And then over here, this will tell me what it is. 60 divided by 4 is 15. Okay, so way up at the top when we first started, that means this was supposed to be a 15. And if we check it, which we don't have to do this for each one, but just so you see, if I plug in a 15 now instead, take out the x, this is just a placeholder, put the 15 in its place. Now I have a true proportion, because when I check this back, 3 times 20 is supposed to be equal to 4 times 15. And now they are equal. 3 times 20 is 60. And 4 times 15 is also 60. That tells me that the 15 that I got for my answer is right. Next one. Number 2 is 13 over x equals 5 over 8. So here we go. And since they're equal, that's a proportion and cross multiply. So I'm going to start with these two. 5 times x needs to be equal to 13 times 8. So 5 times x is just 5x. And 13 times 8, I'm just going to plug it in. Got 104. Okay, so cross multiplying is done. Now I'm going to divide by whatever's in front of the x. So I need to divide both of these by 5.
Can you share your screen with me again, please?
Yep, one sec. Did it come up?
Yeah, it's up. I'm sorry.
That's okay. All right, so let me go back here. We cross multiply. This was the setup. This is what we get after we finish the multiplying. Then I'm dividing by whatever's in front of the x. Whatever you do to one side, by the way, you got to do to the other side because they're equal. So I divided both by 5. And that way the 5s, 5 divided by 5 is 1. So the 5s cancel, and all that's left with, all you're left with on the left is the x. And then I'm going to plug in 104 divided by 5. I got 20.8. You will get decimals and some fractions for these types of problems. They're not going to all come out as whole numbers, and it's okay. If you're not sure if you did it all right, just plug it back into the original proportion like I showed you in the last problem. Plug the 20.8 in right here, and then just see if you get the same thing when you cross your answers. Okay. This one here, I mentioned it, but we're going to go through them just to make sure everybody understands. When you're asked if something is true or false, or if you're asked are the ratios proportional, you're just going to cross multiply and check and see if you get the same thing. So essentially what they're asking is, are these two ratios, are they actually equal or not? Let's find out. So 4 times 15 is supposed to be equal to 3 times 21. 4 times 15 we just did in the last problem. That's 60. Now it's just 3 times 21.
No,
No,
it's going to be 63.
right. 3 times 21 is 63, not 60. So since these are not equal, this is not true. It's not a true proportion. You either write that or you write not true is the same thing as false, obviously. So you can write either one. Because these did not come out to be the same. Okay, let's look at number 4. Use those. Are those ratios equal? Do they form a true proportion? Let's take a look. 2.5 over 2 is supposed to be equal to 10 over 8.5. Okay, so are those true? Let's see. 2 times 10 is supposed to be equal to 2.5 times 8.5. All right.
Nope.
What did we get?
No.
21.25.
Right. So 21.25 over on the right. 2 times 10 is obviously 20. So those are not the same either. So no, this is false also. Good. Okay. All right. So here's the last topic for today. This is some different uses of them, but there are just an infinite number of uses for proportions. Anytime a question gives you 3 values and asks you for a 4th one, you can use a proportion to solve it. Okay, so according to the Journal of the American Medical Association, hospitals that routinely staff with a 1:8 nurse-to-patient ratio experience 5 additional deaths per 1,000 patients than those that staffed with 1:4 ratios. That's true information as of 2002. If the local hospital has decided to follow the 1:4 nurse-to-patient ratio, how many patients can they treat if they have 120 nurses? So let's go through some of this real quick. They gave you additional information here that you don't need, just as a background. For example, this 1:8 thing, it's not needed. It's just to tell you that if you use this ratio, which is high, 1 nurse to every 8 patients, if you use a ratio that high, you're going to have a higher death rate, 5 additional deaths for 1,000 patients. So instead, the hospital has decided to use the 1:4. That we do need then. So it's 1 nurse.
Lost you again.
Did I? Okay. To 4 patients. I'm just writing it down and I'll reshare it.
Oh, okay. You're back.
Okay. So let me say this again. The hospital has decided to follow the 1-to-4 nurse to patient ratio. Is nurse for every 4 patients. So instead of being overloaded, having to deal with 8 patients, they only have to see 4 at a time. So this is the given ratio. They want to know how many patients can they treat if they have 120 nurses. So I'm going to jot that down.
I have a question.
Yep.
So basically, on this problem here, we don't need to pay attention to nothing at the top. Just if the hospital decides to follow the 1-to-4, how many patients can they treat with it? So all that stuff at the top about 1 to 8, 1,000 patients has nothing to do with the problem, right?
Exactly. It's all just context information for you to understand why you would go with a lower ratio, but it has nothing to do with this calculation at all. So when I set these up, I go with the ratio that I'm given with the full information. So 1-to-4 is a full ratio, and I know what each one means. The 1 is the nurse, the 4 is the patients. Then I find another piece of information, and in this case, it's that you have 120 nurses, and then double check that they're asking the correct question that deals with the ratio that I have. So here's what I mean. I'm going to start with 1 nurse over 4 patients. I'm going to label everything so I know what I'm doing. And then on the other side, since these are equal, I keep the nurses in the top and the patients at the bottom. They gave me the fact that we have 120 nurses, so that has to go up here. They're asking for how many patients, so that's what I don't know, and that's going to go with the patients down here. And so here is my proportion all set up. Then I can cross multiply. So starting with the 2 that have the variable, so it's just going to be 1 times x. And that's going to be equal to 4 times 120. 1 times x is just x, because we don't write the 1. It's unnecessary. So we don't even have anything to do here. We won't have to solve. We'll be done once we figure this out. 4 times 120 is 480. And so here's my answer. If they have 120 nurses on staff that day, they can see 480 patients safely. That also means if there's some sort of crisis, like a pandemic, for example, and 500 patients walk through the door, or 1,000 patients come through the door, what will happen?
They'll need to go to the, they're going to be back up to that 1 to 8 or something.
Yeah, which means that people are going to start to die because they won't be able to care for them. They'll be overloaded.
Right.
So we either need to call some more nurses in, bring them from somewhere else, like New York, what New York had to do, or we need to send them elsewhere if there's another hospital in the area that doesn't have so many people in it. Okay, these all have real life implications. Okay, let's take a look at, let's see how many we have left. We'll do these last 2 because the other ones are practice. All right, so you burn 95 calories when running 10 minutes on a treadmill. How many calories would you burn if you ran for 18 minutes? So again, just to kind of talk through what I hear when I read this to myself, I see there's 3 values given to me and they're asking for a 4th. That's a proportion. I can do this with a proportion. I can do this other ways, but a proportion works great for things like this. So I'm going to start with the 90. Go ahead.
On something like this, it don't matter how we write it. That's my question. Like 95 calories over 10 minutes or 10 minutes over 95 calories. Long as we put the minutes with the minutes and the X with whatever's missing, it'll still come out the same, right? We'll just have calories over minutes or minutes over calories, right?
Right. That's a good, glad you brought that up. That's a good question. When you start, you start it any way you want. There's actually, for every proportion that you set up, there's actually 6 different ways you can do each one. You don't need to obviously do this thing 6 times. What you need to do is be consistent, which is what he just said. I tend to go with the order that I see it in, but you don't have to do that. I tend to go with the 95 calories over 10 minutes if that's what I see when I start. And that's what I wrote while he was talking. And then that way, I keep the calories in the top and the second ratio, and I put the minutes down at the bottom so that they're equal. But what he said was, couldn't we just do 10 minutes over 95 calories? Sure. That just means that when you go to write the other one, keep the minutes in the top instead and the calories in the bottom. Doesn't matter how you do it, you just got to be consistent. So let's go back here. It says how many calories for 18 minutes. So 18 minutes is what I have, and calories is what I'm being asked for. So this would be one setup. If I set it up on the other one that I wrote, 18 would be in the top and X would be in the bottom instead. If you look here, no matter how you set this up, as long as you're consistent, the 10 will be diagonal with the X no matter what. And the 95 will be across from the 18, no matter what. And that's why it doesn't matter. So just be consistent and you will come out with the same thing in the end. So it's going to be 10 times X equals 95 times 18. Okay.
17.
What was that?
1710.
1710? Oh, from over here? Okay.
Yeah, for 95 and 18.
Okay. I believe you. And then we're going to divide both of them by whatever is in front of the X.
X will be 171.
Right. Okay, so here's my answer here. And the X was up here with the calories. So we answered the question and we're done. Okay, let's see if we can get this last one in before we run out of time. Okay, so standard dose of an antibiotic is 4 cc's, which is cubic centimeters, for every 25 pounds of body weight. At this rate, what would the standard dose be for a 140-pound woman? Okay, anybody in the medical professions, medical assisting, nursing, anything, the LPN, these are things you're going to be asked all the time in those classes. So let's get this set up. I'm going to go with 4 cc's per 25 pounds because that's what I see first. That's just my preference. And that means on the other side, I need to keep cc's in the top and pounds in the bottom. If you go with a different start, just make sure that your stuff is lined up and is equal. So the other piece of information that they told us was that the woman weighs 140 pounds. So that's going to go down here. And they're asking how much would we give her? So how many cc's does she get? So here's it set up. Next, we're going to cross multiply. 25 times x is equal to 4 times 140.
560.
Over here, you got 560. Okay. Then, so what do I do now?
Divide by 25.
Yep.
And you're going to get 22.4.
Okay. Divide this by 25. Divide this by 25, so that the 25s cancel. And what was that? 22.4?
Yes.
Okay. 22.4 cc's then. All right. That about wraps it up for today. Do we have any questions for me?